Snell's law explains the relation between the angle of incidence and the angle of refraction. To analyze this, let us assume a situation where a person is drowning at the point B and A is the point where we are observing the incident and X is the shoreline. In order to save the person, we need to travel a certain distance on land and a certain distance in water. We know that we can run faster on land than we can swim in water. So, the speeds on the land in water, the final path that one has to follow to reach the person is ACB. And this path takes the shortest time of all possible paths. If we want to take another route, then it will be longer. So if we plot a graph for time taken to reach the person against the position of any point when we cross the shoreline, we would get a curve something like this. Now, the time taken to travel from E to C is delta t and time taken to travel from D to F is delta t because we have assumed this D and C points are equal. And where C is the point on the shoreline and corresponds to the shortest of all possible times. Here we are assuming that there is essentially no change in time between the path ACB and ADB. Now let us calculate how it will take from A to B considering these two paths ACB and ADB. Now draw a perpendicular DE, which is we see that the path AD on the land is shortened by the amount EC. On the other hand, in the water, by drawing a perpendicular CF, then we can find that we have to go extra distance DF in the water. In other words, we gain a time that is equal to go through the distance EC on land but we lose the time that is equal to go extra distance df in the water. These times must be equal since we have assumed that there is no change in time between the two paths. Now let the time taken between to travel from E to C and D to F be delta t and V1, V2 be the speeds of running and swimming. So accordingly from the diagram EC is equal to V1 delta t and DF is equal to V2 delta t. So from EC by DF is equal to V1 by V2. Keep this expression aside. Coming to the right angle triangles. Here from this diagram we can observe DEC and the DFC. They are in the right angle triangles. To make it clear, I have drawn here. See, these are right angle triangles. From this we have to take a sin I. So what is the sin I? This is one of the trigonometric ratios used in the right angle triangles. Sin theta is equal to opposite side by hypotenuse. This is the opposite side and the hypotenuse. So according to this sin theta, so sin I from this triangle DEC, sin I is equal to EC by DC, where EC is the opposite side and the DC is the hypotenuse. Sin R is equal to DF by DC. If we take the ratio of sin I by sin R, then EC by DF is equal to V1 by V2, which is nothing but N2 by N1. This one, if we want to understand clearly, you can go to the relative refractive index and we can understand. Therefore, N1 sin I is equal to N2 sin R. So, N1 is a refractive index of the first medium and n2 is the refractive index of the second medium. And I is the angle of incidence and R is the angle of refraction. Therefore, we have find relation between the angle of incidence and the angle of refraction. This is nothing but this is called as a Snell's law.